Alrighty folks, we are going to be starting section 9.2 tonight and looking at solving systems of equations by elimination, which is a completely new method for you, but maybe a little bit easier for some of us. So we're going to start off this fantastic phenomena by looking at a very basic set of equations. So have a look at these ones here. Two very simple equations, 6 and 4 do in fact make 10, 3 and 5 make 8. What you may not know is that you can actually add equations together. So I can add these two equations and I still get a true statement. So 6 plus 3 is 9, 4 plus 5 is also 9, and 10 plus 8 is 18. Well, look at that, also true. Not only can you add equations, you can also subtract them. The only difference here is that when you subtract, you have to subtract everything inside the brackets. So you have to use the distributive law with that negative sign out front. So you're going to go 6 minus 3 is 3, 4 minus 5 is negative 1, and 10 minus 8 is 2. And sure enough, 3 minus 1 is 2. Cha-ching! So you can add and subtract equations. Well, why is that a useful thing? Well, let's throw some variables in there, and that still holds true, and we'll see why this becomes useful. Okay, so here's a system of two equations. You could use, what's the word? There's substitution to solve that. What we're going to do instead is we're going to add these two equations together. And the reason why I'm adding them together is I want you to notice that my y terms here are going to cancel out to 0. Because I'm going to go positive y minus y is just going to cancel out to 0. But if I add the other two terms, so 4x and 3x equal to 7x, and then 9 plus 5 is equal to 14, well, that's a really simple equation to solve. Just divide both sides by 7, and you get x equals 2. Okay, and that solves both equations. We just need to figure what y is, and we can use either equation 1 or equation 2 to do that. Okay, let's use equation 2 here and substitute in for x and then solve for y. And we get y equals 1. So x equals 2, y equals 1. There's our solution to that question there. Okay, without having to do substitution. So that might seem a little bit easier for some of us. Sorry for that interruption. Okay, so there we go there. That's elimination. So let's have a look at another example and see if we can make this work for us as well. Okay, so consider this system of equations here, and I again see that I have a positive and negative y, but you'll notice that if I add these, they don't cancel out. That doesn't help me. In other words, if I add them, this is what I get. I still have two variables, but only one equation. So that's not going to help me. What would help me was if this y was a 2y, but it's not. It's just a single y. But if I were to multiply everything in equation 2 by 2, that would make that into a 2y. Okay, so let's do that. Multiply everything here by 2 and a little bit of magic. Ba-boom, there we go. And just so you know it wasn't magic, I just paused the video. Don't start getting me in trouble or anything. And now I can add these just because I multiplied everything by 2. I haven't changed the equation because we know we can do it with any equation. I get 29x. This cancels out to 0 equals, well, 24 plus 92. It's going to be 6, 116 it looks like. Okay, divide both sides by 29, and sure enough, x equals 4. And all we have to do then is plug that into one of the other equations to solve for what y is. And there you have it. Okay, so I'm going to give you a question to work on, and we'll end the video after that, and then you can see the solution in video 3. So try this one here. Did I say video 3? I meant video 2. Anyway, try this question. Okay, this time I have two y's here for you. Okay, so they're both positive though. So what I want you to do is I want you to subtract. I'm going to call this equation 1 here, this equation 2. Subtract equation 2 from equation 1, or vice versa. It doesn't really matter. And then you'll eliminate one of those y's. Or you'll eliminate the y variable rather, and then you can solve for x. So go ahead and give that a shot, and I'll show you the solution in the next video.